Alright, so question 1a is to differentiate the square root of 4 minus x. So first of all, let's identify this guy as needing the chain rule. So we need to find an inner function and an outer function. So I'm going to start off by letting u, our inner function, equal 4 minus x. Therefore, du dx, the derivative of u with respect to x, is given by -1. So our outer function then is going to be the square root of u. So we're going to let that equal y. So then dy dx, dy du is going to be given by, we can rewrite this as just u to the power of a half. So our dy du then is going to be power at the front, so a half at the front of u, and then we subtract 1 off the power. So we have 1 divided by 2 minus 2 on 2, which is just, this guy's just 1, subtracting 1. And this gives us 1 on 2 u to the negative a half, which we can write as 1 on 2 to the square root of u. So now we've got du dx and dy dx, we can use the chain rule, which states that dy dx is going to be given by dy du by du dx. So in green, we need to find dy du, which we did right here. So we substitute that in, and we get 1 on 2 root u, so this guy. And then we have to multiply, we'll do that in orange, by du dx, which we found here, which equals -1. So we're going to multiply that by -1. So now we've just got to clean this up. So dy dx, which is our derivative of the square root of 4 minus x, is given by -1 on the square root of 2 by the square root of u. But we know from up here that u is equal to 4 minus x, so we substitute that in, and that's our answer. So for part B, we were asked that if g of x equals x squared sine of 2x, find the derivative, g dashed, of pi on 6. So we're going to start out again by just finding the derivative, and then lastly, we'll substitute in pi on 6 to find the exact value at that point. So let's start off by acknowledging that this guy is going to be a product rule. So we're going to let u equal x squared and v equals sine of 2x. So du dx is going to be 2x, just power at the front, 1 off the power. And dv dx is going to be sine. If you look in the formula sheet, we should find that the derivative of sine of ax goes to a cos of ax. So in this case, we get 2 cos 2x as our derivative. So then all we need to do is multiply across this way and add them together for the product rule. So the product rule states that we take u and we multiply that by dv dx, and then we add on v times by du dx, and that will give us our dy dx value that we're looking for. So let's have a look at that. So just in green for this part, we'll get that dy dx is equal to, So pick up u, x squared, multiply that by dv dx. So dv dx is all the way over here. So multiply that by 2 cos of 2x. Now we need to add on, and we'll do this in orange. So we need to add on v times du dx. So v was just up here. So we have sine of 2x. And then we're going to multiply that by du dx, which is 2x. So when we clean this guy up, we should get the dy dx is just equal to 2x squared cos of 2x plus 2x sine of 2x. Now we need to evaluate dy dx at the point x equals pi on 6. So that's just going to give us 2 by wherever there's an x, we're putting pi on 6, so put the pi on 6 in a bracket and then square that, and we still multiply that by cos of 2 by pi on 6, so just 2 pi on 6. Then we're going to add on 2 wherever there's an x, again we're putting pi on 6, sine of 2 pi on 6. So now we've just got an expression, and we're going to need to use our triangles and other trig tricks to be able to evaluate this. So again, let's just go through one more step of cleaning up. So we're going to have, just for this little bit here, we're going to have 2 pi squared on 36 multiplied by cos of 2 pi on 6. I'm going to change that back right now to be pi on 3. And then we're going to add on to that pi on 3 multiplied by sine of pi on 3. So I don't know about you guys, but I like to think about angles first in degrees because that's how you're taught as a kid. So pi on 3 is, 180 divided by 3 is the 60-degree angle that we're looking for. So if we just shoot up to this side bit for a little bit, we'll just have a look at our exact triangles. So we've got 2 of them, and the one that's useful to us in this case is going to be the one with a hypotenuse of 2, still got a right angle, and then we've got a 1 and a root 3. So within this, we know that the one opposite 1 is going to be our 30-degree angle, and the angle across from root 3 is going to be the 60-degree angle. So now we know that cos is CAH, so we know that cos of our angle, so we'll pop in the 60 degrees, which is again the same as pi on 3, is equal to adjacent on hypotenuse. So our adjacent is 1 on this triangle, so this guy here is the adjacent, and the hypotenuse is this guy here, so 1 on 2. So now we know that cos of 60 degrees is 1 on 2, so we can put that in this bit of information. So this is just a half, and then we need to find sine of pi on 3. So I'll do that in orange. So we know sine is SOH, so we know sine of 60 degrees is going to be equal to opposite. So let's have a look. Opposite is root 3 on our, again, hypotenuse, which is 2. So we know that this guy here is just root 3 on 2. I hope you can read that. So the lucky last bit is just to express that all together and make it nice and easy. So hopefully you can see that this 2 and this 2 will cancel, and we'll just combine the 3 and the 2 down the bottom to give 6 on that side. So our final answer should be something along the lines of this. We'll have pi squared on 36, which takes care of all of this bit here is here. And then we've still got added onto that pi times root 3, and then we combine again that 3 and that 2 to be 6 down the bottom, and that takes care of all of this bit here. So that's our final answer.